All right, hey everyone, welcome back to week 25 of Hobby Kernel Dev. Let's get right into it. So today I'm going to start by explaining the bug from last time, and then we'll continue with all the exercises. So last time I was working through the lab here, this lab, and my plan was to actually work on these last three functions, which are the only ones remaining for me in exercise 2. And as part of doing that, I discovered a pretty critical bug. Let me pull over my code. Yeah, kind of chaotic window. Let me clean this up really quickly. Okay, actually, let me just quickly make sure that things still compile and run. I kind of hope they should. I think that means it's working. Okay, yeah, so right, last time I was working, let me find the function, so load icode. So last time I was working on load icode, and what I discovered was after changing the page tables into the page tables for my first process, the init process, which happens by loading CR3, I discovered that after that point, I was no longer able to make function calls. If I tried to make a function call, the kernel would crash and trigger like basically infinite reboots. And basically I didn't make any progress, and I spent the whole time debugging this very interesting and strange kernel reboot crash, which I will now explain. Before I do that, I'm just gonna go do a quick test in the chat to make sure things are working with the chat widget. It might take a little bit of a time for that to start up. Hello from Pakistan. Hey, Uwan. Hope that's how you say your name. Welcome. Glad to have you. Looks like the chat widget is working. Awesome. I also want to test out a couple cool new features we have this week. I learned how to add some commands in the chat, and so I'm just going to try them out really quick. So I have a tools command, and I wonder if that works. It actually does not seem to be working, which is kind of unfortunate. Okay, no, it just, okay, that's actually cool. That actually just worked. Maybe there's just a bit of latency. So yeah, my tools command, if anyone asks about tools. Although interestingly, okay, it just takes a bit of time for it to appear in the chat thing. Okay, so these are the tools I'm using because people tend to ask me. So I'm using VS Code with this theme, Vim, iterm2, tmux, lazygit, fork, gcc, gdb, qemu, make. I also have the resources command, and this will link to my resources page that I have for people, which is my recommendations on how to get into low-level programming and development. Wow, it seems like there's like about 10 seconds of latency. So I got my resources command, that's pretty cool. Uwan says, have you studied electrical engineering or computer science? Yes, so I studied computer engineering for an undergraduate degree. So I did actually study some of this stuff. I have my testing out the Discord link. I have about 10 years of experience, I would say. Yeah, kind of going back to when I kind of first started programming. And lastly, I have my course command, which is a link to this MIT course that I'm following. And when that appears, yeah, okay, neat. That's pretty cool that that's all working. I feel like a really pro streamer now. Also studied CS, having 3 years of experience. I could never write anything beyond bootloader. It's funny that you say that because I feel like the bootloader is actually one of the most challenging parts of this, not in terms of how big it is, but how, especially for x86, how relatively esoteric it is. In my view, actually writing the kernel is much easier than writing the bootloader. Yeah, but you know, take your time. Eventually you'll get there, but yeah, even the bootloader is pretty intense. So awesome. It seems like our chat's fully working. So I'll continue with this explanation. So basically, we have this bug where I could not make any function calls after the CR3 load to reset the page tables to be the environment, like the user process page tables. And I ran into this because I was trying to use panic for debugging or maybe print statements or something. And I was like crashing the kernel. So I'm just going to quickly reproduce this. I'm going to jump to where the bug is. And I'll just jump straight there. The bug is in boot map region, which is in the function that is basically used to set up a lot of the page tables. It's like a utility function for setting up the page tables. And I fixed it now, but the critical bug is right on this line. I'll actually load up my Git client to show you the diff. It's a bit of a messy diff right now with a lot of working stuff, but here's the actual diff that fixes the bug. So I'm gonna remove that diff, and now, I'm gonna come back to the code, and you can see that says current page dir is used here. I'm gonna actually run the kernel, and we're going to observe the bug. Actually, wait a sec, no. It didn't reproduce the bug because I have this assertion test thing now. So let me just quickly undo that. So in the process of trying to debug this, I added some more tests. Where is it? It's called something custom. Yes, right here. So in my code that sets up the virtual memory for the process, I was actually using this handy function, which we were previously using for kind of unit testing the kernel's virtual memory, and I'm just kind of repurposing that to be able to check the user process's virtual memory. I'm going to uncomment this, and I believe we should now reproduce the issue. Interesting. Did I? Okay, what? 249. Okay, then this is something else. This is a bit of a, this check is extremely explicitly checking a certain page directory. It's right. I'm gonna also, that's also effectively a unit test. Okay, I have my, something, okay. That's weird, okay. And now this is failing, interesting. Okay, I don't want to spend too much time debugging why I'm not able to reproduce anymore, although this is kind of weird. I need you to in tmap.c. Right. Interesting. Okay, that's like super weird. I'm not going to spend time debugging why I can't reproduce it anymore. It will, when I clean up the Git, maybe we'll get there, but basically just to get straight back to the point. So we have this function boot map region. And this is a utility function that's used for setting up virtual memory. It's used from a few contexts. So the main context is for setting up the kernel virtual memory, where we call to like map regions of memory for certain use cases. We just call it various times with various arguments. And it was initially meant to set up the kernel's virtual memory, but then I also ended up reusing it to set up the kernel portions of the user space memory. And the bug was that here it was hard coding the kernel's page tables, the kernel's page directory, which works if this function is only ever used to modify the kernel's page tables, but is totally wrong if we're intending to pass kind of like arbitrary other page directories. And so the fix is to actually, is to actually use the argument, is to not hard code. And then that basically, the reason that caused a bug was because this is the part of the code that handles propagating permission changes. What that means is if we want to map some memory as writable, we're going to need to mark the page table entries as writable, but I'm pretty sure we also need to propagate that permission bit also into the page directory, and that's what I was forgetting. And I was forgetting to do that, and so the end result was that it was for the stack. And the stack memory was mapped, but it was not writable because I didn't set the page directory entry bit as correctly as writable. And that was, so later on, that memory is not writable, but I was trying to call functions, which involves mutating the stack memory to push arguments onto it. And that was crashing. I was gonna take the chat. Are you doing development on some type of open source OS, or you started from scratch? So I did not start this from scratch. This is just from this MIT course. This is like the OS that kind of comes with the MIT course, and you kind of build onto it. So I totally did not start this from scratch. And basically, I wasn't able to make function calls because the stack memory was not writable. But then with this fix, I'm now actually properly using the given page directory. And so with this change, I'm actually propagating the permission bits correctly. So now I'm going to take a bit of time and just go clean up all this messy stuff in Git. Because I just kind of want to get things back to a kind of a cleaner state. So that's the actual important change. So I'm going to separately commit and stage this. Call that, I'm just gonna call that virtual memory maybe. Fix properly propagate permission changes previously was entirely hard-coded to use the current pager instead of the given one. Okay. Did you take any advanced OS course before doing this? No. This is my first time doing an advanced OS course, literally right now. I only took a very basic one in university. Yeah. Okay. So just to check, our kernel should be running. Okay, so this is working now, and the reason I know it's working is because it's hitting the 1, 2, 3 panic, so function load icode is what we're trying to do, and it's properly hitting this panic, and that function call is working. So that's how we know this bug is fixed. So I'm just gonna go through, this was some stuff for trying to unit test, or like reuse the existing test. And so basically last time I was very, very close to debugging this. And I had this final idea towards the end to reuse some existing like effectively unit tests to validate the user page table. Those tests were originally hard-coded to only be used for the kernel page table, but I figured all those tests should be passing for the user one too. And that's how we discovered that actually there were some problems with the page directory entry bits, and sort of discovered the difference between my kernel page tables, which were fully working, and the user page tables. So all of this is actually code I do want to have. So I'm not going to delete any of this. This is all kind of junk. Don't need that. Don't need that. I had this no inline. That was kind of for debugging. Okay, right, and this is truly just debugging stuff, like really just manually querying the page tables. So in this test, I had this one pointer that was crashing, basically. That was the stack pointer that was crashing. And here I'm explicitly querying my page tables for that pointer. Number one, I'm trying to verify that that pointer is mapped to physical memory, which should have been the case. And that's why I'm asserting that this page info is a valid pointer. And number two, I also want to assert that there's a page table entry. And both of those were true. So I don't need this anymore. I don't need this crazy thing. This is me asserting the right bit on, the page directory entry. And then, here's just, check load iCode. That's unrelated. That's like my unit test. I think it would actually be good to keep some of this stuff around though. So, and I was kind of curious why I couldn't reproduce the issue and set up VM. So just, so I don't want to take too long on this because I actually feel a little bit strange that I wasn't able to reproduce the issue. So now, right, the 982 failed in pmap.c. Right. Page to core. And so that's correct. Right, this is what I literally just did. 20-second break. Be right back. All right. But so this is just called by, wait, sorry, so interesting. Who else is calling this custom thing? Am I calling it in multiple places? Okay, so the bug is active and this thing, right, so I need to uncomment that. And now this is the very curious thing that's failing also. But I'm also calling it here. I think that's why. Okay, I think this time it should reproduce. Okay, there we go, there we go. Here's the bug. It's just rebooting over and over and over and over again because I injected the bug back here. And if I fix the bug by not using the current page dir, it does not do that. It actually panics properly. So okay, good. So that just confirms that you know, it actually works. So good. So now let me go back to here and clean everything up. So I don't, but I was saying I do actually think it would be cool to keep these in here. This little consistency check. So what I'm going to do, I'm going to have a commit. Where is it? pmap.c. So I had just a commit. All right, this is a bit weird though. I think I wasn't quite thinking clearly last time. Check current page. Yeah, okay. So I did this kind of strange thing where I had this like check current page dir one, which all the existing code was calling, and then I made this kind of strange like custom thing that just forwarded it, but in reality I don't need that. I can just directly find all the places that use the custom. So this is basically the only place that I want. I'll just change this to core. Yeah. And I don't need all this indirection. Yo, Digitalized, good to see you, man. How are you? Nikhil, what's up? Yo, Beep Love. How long have I been programming? 10 years. Yeah. He's been programming for the last 10 years. Straight. Yeah, I've been programming for about 10 years. Yeah. Yo, Jan, what's up, man? How are you doing? Are you having a good summer? It's super hot here today. Okay, let me just quickly test that this is still working. But then my header is wrong. Core, yep. Oh, oh wow. I did not want to spend all this time. Okay. There's this other custom thing here. Interesting. This was kind of a redundant check, basically. Static declaration 921. Also, I need to do this like save, like auto save. Yeah, I need it. I can't. I don't know how I've been living without this. I need that. I need that auto save. Yeah. Yeah. What up, Sid? How are you doing on this fine Sunday? Hope you are doing some crab activities. Does this work now? Yeah. Okay, I didn't fix 921. What is going on? Okay, so I just declared, I was like forward declaring something for, wait a sec. Static declaration follows non-static. So am I being dumb? Okay, so I don't know why this was static. Previous? This is so crazy. Okay, yeah, so this, okay, right, so now this cannot be static anymore because it's actually being used. And I'm going to get rid of the forward declaration. I'm going to just move this, oops. Oh, yeah. Sorry, what happened? Okay. Backing up. Okay, remove the forward declaration, delete this thing, and paste it below. So now I think that should actually be static. And this all works. All right, cool. Start your Twitch channel. Dude, I tried Twitch once earlier on and no one joined the stream. So I don't know. I think I need to find a way to multi-stream it to both, but I didn't figure that out, how to do that yet. I think there's ways to use FFmpeg to do that and not pay some service for that, but yeah. All right, let's get this commit looking good. So in this commit, I'm trying to basically expose a different function. Don't know what that is. My header needs to change. All right. So in this commit, previously we just had the check page kerner, but then I want to expose a new one internally that lets you control the argument because I don't want to update all the callers. So I'm adding this core thing and just forwarding it to that. Cool. Planning on doing leak code and learning Rust during a stream today. Right on, dude. Good luck. I think you were doing some interviews or something, right? Digitalized. Yeah, hope those are going all right. All right. So add check kern pagedir core. Yeah. What up, Alex? Alex Tabitha. I do use OBS. Is there community support? That would be awesome. Okay. Maybe if you could like help me or like link me to that or something like that, maybe I can try that next time. I would be interested in doing Twitch. I feel like, I mean, it's the classic place for streaming. Gamozo streams there all the time and has a massive audience there, so I feel like that would be pretty cool. I'm just still cleaning up this diff. Yeah, bomb one interview, but I can only improve. I mean, yeah, dude, everyone bombs interviews sometimes. I've bombed so many interviews. Okay, I think I don't need this. So now I'm trying to actually commit specifically this thing. I don't really want this anymore. Yeah, I'm trying to do my, oh wait, no, that's actually not what I want. In my env set, I want to be doing this on env page dir, right? So we set up the VM and then we validate it. And this should totally work. Still working, that's good. Yeah, I kind of feel bad about just spending like the stream cleaning up this Git stuff, but whatever, I didn't really have time to do that outside the stream. Okay, so now we're basically just using that API that we added in the previous commit. Now we're using it in this commit. And where's that bug fix? Or I already actually committed it. It would be cool to add that actually in the same commit that that fixes the bug, I'm thinking. So how am I gonna do that? Here's what I'm gonna do. I'm going to switch over here. Oops. So yeah, because I added this fix, but I actually want to add that in the same commit that I add the test for this actually. So what I'm going to do is I'm going to stage all of this, and I'm going to move this up in the history. Then I'm going to apply, and then I'm going to, so now I have, switch back to fork. Sorry, So now, okay, so basically it was as simple as this, I guess. And now I'm just going to amend this into there. So now we have a nice commit where we fix the bug and also add the test, and we can test caller, and we can do that because in the history we previously added this API and stuff. So that's kind of nice. Right back here, I think I need this. This is all the current work that we're doing today, basically. I can remove this. I can remove all of this debugging code, all of this really embarrassing debugging code. And now we're actually ready to kind of get going with the check load icode stuff. Yo, Handle, good to see you. Hope the time zone's working out a bit better. Check load icode. I'm just gonna actually even commit this thing too. So here, Cat Flare, how's it going? Check region alloc. Was there a problem with check region alloc? This is in init.c. I don't think there was a problem with check region alloc. Yeah, no, there was nothing wrong with that. So that's good. Woke up early, nice. Rise and shine for some OS development. Today I need to code. What are you coding today, Catflare? Some and this. And this no inline thing is kind of crazy. I don't really want that. What did I code? This is what I want. Okay. Does that look right? So in this commit, what check what I code doesn't return void though. Or wait, no, load icode. Oh, right, that's not related. So I have check load icode, which I'm calling, and the idea was to have a very basic version here, right? Okay, here's my comment that I was leaving for myself, which I can now fully just delete. And I'm gonna add everything but that. So here's my, so it's like add check load icode and call. Maybe just add. So that thing's there. Then we have the production code, which we're gonna work on. And this thing's there. Good. What's this? Why is there this void thing? 2 voids. For some reason, I wanted to call bootmap region outside this translation unit. I kind of forget. All right, I'll fix that all up later. Kernel, as always. Right on, good luck with your kernel. 20s, time goes so fast. That's so true. Yeah, all right, Alex. This is the first time I'm using my handy command, but yeah, I'm following this MIT course. And that's why the branches are called lab. Yeah, just install CrowdStrike. Yeah, I need to port CrowdStrike into my OS actually. That would be a good port. Then they can crash my OS. I mean, I already crashed my OS enough, so loading Ucode and patching it during runtime. Ucode here just means like user code, or did it say Ucode? I don't know. I'm not quite sure what you mean by Ucode. Like microcode, I guess is what you mean. No, I'm still working on the absolute basics. All right, let's get actually into this. Yeah, honestly, I don't know anything about microcode. I mean, it's not in the immediate roadmap, I guess, because I'm not planning on running this on like a real CPU with microcode. Yeah, I truly don't know anything about microcode. Okay, so, you know, my Git is so messy. There's all these panics that are getting removed, and I guess I want that. I want this, and I am kind of not remembering why boot map region is so public now. Also, it's too many files open. Okay, boot map region. What? Boot map region. Who is using this? All right, it's because it's being used. Oh, that's why. So now we're using it outside that translation unit actually. So that's why we needed to get rid of the forward declaration. Oh wait, what? Oops. Okay. So first things first. So here's update the panics. So now, and then the final piece of this was, so we're trying to expose this as more public. So therefore, oh wait, boot map region. I think I got rid of the void accidentally. So now it's just void. Sudara, what's up? What's up? Thanks for joining, man. Hope you're having a nice day. So this gets committed. Yeah, Sudara, I'm like right after this, I'm gonna try this experiment, and I'm gonna, after the stream is done, I'm gonna film like a little recap, summary video, like 5 to 10 minutes, I think, just very casual, and then upload that as a separate video for a bit more broad context about what's going on. And in it. Yeah, I think with that way of doing it, it will be actually very little work. Okay. Public. Okay, so now we've finally got like my Git under control. This commit is pretty weird actually. Why is this? I thought I did something very similar. Oh, this was a mem init, so we can actually just amend that into there. Ooh, actually, whoops, I think it moved a bit too fast. Did I do that right? Okay, I don't know where that hunk went. Is that here? Okay. Does this compile? Mem init. Oh, I got rid of it. That's what happened. Yo, what's up, Tassilo? I actually don't know if that's how you pronounce your name. We didn't talk about that. Dude, great meeting you yesterday. Yeah. All right, 20-second break. Be right back. All right. So mem init. I accidentally deleted this. Or yeah. Panic. So this is what I meant to refresh. So I meant to just amend this into the panic commit, which I've just done, to kind of just clean up the history, get all these panic updates together. And now, finally, after 40 minutes of work, I finally have a clean Git working tree to like start the stream for today. So interesting. Let's do it. Load iCode. You need to parse an ELF binary image, much like bootloader already does. Load its content into the user address space of a new environment. And I need to kind of remember exactly what that's talking about. What that means. I keep forgetting where this thing is. It's all in env.c. So we got a bit of a start last time. So the idea was we need to parse the elf. So we have the buffer, convert it to an elf struct, check the magic. Now it's time to get the program headers. And yeah, all right. And here's where we're going to, so here we're iterating through each program header and then interpret the program header and map things into memory using region alloc, I believe. And it gives all these nice comments about how we should do this. Let me pull up my unit test. Oops. Just so I can have that close by. So here in my actual test, I actually am calling this with a real elf. So we'll be able to observe this. I'm just noticing that this thing is actually in the wrong place. So that hunk where we change the type def actually belongs in this thing because we're adding callers. I mean, in retrospect, no, it was a bit too early to even add this commit because it's making use of the production code. I'm just going to quickly amend it. And then I guess I will actually move it up to the, oh, conflicts, all right, abort. We'll do that, we'll do that later. All right. So let me stop messing around and do this. So this comment basically tells us everything we need to do, I think. So if header type is not equal to load, continue. Okay, the virtual address can be found in this. So I'm going to take this point to refresh myself on how to call region alloc. You give it an environment, you give it a virtual address, and you give it a length. So at a high level, we're trying to, so that's allocating memory in the process. And if I understand this right, we're basically going to be like, we have this program header, which describes where the program data should eventually arrive at in virtual memory. It also has information on where the data is stored in the ELF binary. So we use the program header to extract and get the information basically about where this thing is and then put it into memory, is my understanding. And I think it even tells us kind of how to do this, which is very helpful. So the size of memory can be found here. So I'm just even going to draft a call to this. It's kind of unfortunate we have this variable named e. VA mem size. So allocate memory in the process, uninitialized memory in the process, and then now we need to copy in the data. And the question is, how do you do that? And also, I don't even know if I have a mem. I must have a mem copy somewhere. Okay. File size bytes from the ELF binary starting at so and so and so should be copied to virtual address there, right? So I'm just, do I have a mem copy? I do have a mem copy. How do you call mem copy again? Destination source int, right? So destination is going to be php. Is that right? VA. I should be able to directly write there, I think, because so if we're in this part of the code, we are fully within the context of the user environment. And using region alloc, it seriously maps memory. It like really maps memory and inserts them. And so when we call that, man, I'm just trying to go back to where I came from. Why is that so difficult? Man, okay. Load icode. Trying to use the Vim way to go back, but the thing that wasn't quite working. Okay, so as soon as we call this region alloc thing, that actually just makes these pointers eligible to be used. So I think it's totally safe to just do this. So that's the destination, the virtual address. And the source is what? The source is binary plus ph offset, right? That's what it says. The PHP file size bytes. That's my initial draft of how I think this would work. Any remaining bytes should be cleared to 0. So no, to do memset bytes to 0, need to do that. Elf header should have, okay, maybe we can add an assert actually. Assert p file size is less than p mem size. Or maybe we don't want to actually assert, but just kind of try to handle it and return an error. Don't assert and just return an error. But that's a little bit messy because it leaves, I don't know, it might leave the process in a bit of an inconsistent state if it already processes a few program headers. All protection bits should be user read write for now. And so region alloc doesn't even take a permissions. It just automatically sets stuff to writable and user space accessible. If we wanted to change this in the future, we could expose an argument for controlling the permissions. So let's see. Yeah, loading is much simpler if you can move data directly into the virtual address stored in the ELF binary. So that's, yeah, so that seems to be the case. So which page directory should be enforced? The user one, that's what I'm doing. You must also do something with the program's entry point. make sure that the environment starts executing there. What? See environment pop TF below. I don't actually know what that is referring to, so I'm just gonna add it to do. The program's entry point? Question mark? Okay, I guess now is a good time as I need to add this memset call. So just to go a bit slower for a second. I'm also just gonna bring up the read elf. That one's pretty handy. Elf. Tab last time. So we can see the section. That's not what we want. We want the program headers. So these are the actual examples of what we're processing. Offset is the offset into the binary image of the elf file. Virtual address is the destination that this should appear at. And file size and mem size, right? So what's the invariant, or what's the condition that file size is less than or equal to mem size? Which, let's see, kind of makes sense. For example, if you have like a BSS section or segment or whatever where it's all zeros, you don't want to actually consume space in the file to store those zeros. And so that's an instance where the file size could be like as small as actually 0, but you might actually want to expand that in memory to like a potentially large amount of memory. So that's a bit of the intuition behind that. And the concrete thing to do there is basically jump to Miro. So if we have, oops, wow, that was kind of strange. Where are all my tools? All right, Miro kind of bugging out today. All my tools disappeared. I'm gonna reload. Okay, then they're back. So just really quickly, just to visualize it, so it's not super complicated, but we have our buffer. This is the segment. So this is like basically one program header describes one region of memory, and so we could. There's no need for this to be an arrow. So basically. So we alloc starting at the virtual address, which is the start here, and then the length here is the mem size. That's the mem size. But then we might have like this amount is like the file size. And then this region to the end of the mem size needs to be mem set to 0. That's my understanding of this point. So how do we do that? We're going to call mem set, meme set. With what? You pass it the destination. And in this case, it's going to be PHP VA plus ph file size 0, and how long is going to be? It's going to be the difference between mem size and file size, I believe. How does that look? So it's pretty important that this doesn't produce a negative number for this thing. And so far, our assertion is guarding against that. We could even move this a bit closer to here, although you could also argue that it's better to do the check early. So I will leave it at the top first. But basically, yeah. This might be buggy or something, but I kind of think it's kind of right. So we basically have this thing. In this case, and oh, interesting, the mem size is 8, but the file size is 4. It's kind of interesting. And I'm also thinking about alignment, actually. Because... So we're region allocating like a region. Like what happens in the... So the absolute safest and most conservative thing to do is just simply zero initialize everything after we region alloc. But I'm just thinking about alignment, because region alloc internally is going to round things up to the nearest page size, which is kind of what they told us. So len, in this case, it's going to be 8. It's like a pretty small number. Actually, just curious breakpoint. Why? Any intuition about why that is? No. Lib.h. Does this like declare data? I don't think so. Okay, I officially have no intuition why there are 8, like what that corresponds to. Don't save. Okay, but whatever. So in our case, we're going to be calling this function with 8 as the length, which is way too small. So we need to round it up to a page size, which we do here. And then we actually do the insert calls. So the end result is that we are going to actually allocate a page of memory into the process. And what? And we, yeah, page alloc. And we are intentionally not clearing it here for performance or whatever, which is kind of dangerous. So we're giving it like a really raw, uninitialized page of physical memory and mapping it into this user process. And it's pretty important to make sure we clear that. Otherwise, all sorts of info leaks are possible by just allowing processes to get like memory that's kind of being recycled from other processes. So that's pretty bad if we were to just forget about memory initialization. So the question is, so maybe just illustrate this one more time. So this is the segment. Oh, I don't know why this is so small. It's like the elf segment. We have the mem size, we have the file size, and we have a 20-second break. All right, be right back. We have a couple things. We have the VA adder at the start, mem size, file size, and needs to be zeroed. Maybe I'll make another rectangle for color. Why did that not work? How? Oh, I did the wrong one. Oh shit. Ooh, okay. Added a frame accidentally. I meant R. So we have this first region is the actual data from the elf. Please let me draw this. Okay. Then we have this part, which needs to be zeroed. It's like, but then, and maybe, but like add another one and not, oh, I did it again. All right. But let's say this was even way less than a page, so it's not page aligned. And can I move this to the back? Send it to back. So basically, this is like the hex 1000 alignment, page alignment. And actually, all of this needs to be zeroed. So there's so if I'm understanding this right, there's like a couple points here. Publish. I'm using this. It's this app called Timeout. It's like a Mac app. So if I'm getting this right, we need to actually zero out this whole region, because the allocator ultimately is going to allocate in terms of page granularities. So it's going to give us, so even if we only ask for 8 bytes, which is like over here, like it's a tiny amount of memory, it's going to give us and really map an entire 4K of memory uninitialized. And so in order to be secure or whatever, if we cared about that and avoid info leaks, we should really be clearing out everything here. So for me, the question is, how do you determine, basically the question is what length do we use for memset? And I think we need to round up somewhere. I think we need to round up the mem size potentially, which is a little bit unfortunate. Ideally, with a different kind of design of the code, region alloc would return some information about this, and maybe we can even modify it to do that, rather than, because otherwise we're kind of, we need to put this code twice in like the API and in the client, which kind of is lame. So it would be very cool if it returned actually the amount of memory. I think it could, yeah. I'm just gonna return len rounded, which I think will be pretty useful. So then this thing needs to return an int. Yes. Yeah, an int. When in doubt, I'm going to use an int. Safe eyes. Nice. Yeah. All right. Then I'm going to update. Oh, interesting. But this thing is not even in a header anyway, so it doesn't matter. So now I can do something like int const int actually allocated. What's a better name for that? Mapped size, mapped len. Naming things is always so hard. Why is this complaining? Okay, that's fake. Okay, I haven't compiled in a while. I'm going to compile. Okay, a bunch of errors. Wait, wait. Okay, what? 338. Where am I messing up? Oh, so now this thing needs to return. I see, okay. Or maybe I can, no, I think, yeah, 0 is the correct thing there. Expected expression before struct. What do you mean expected expression? Oh, I deleted the, how did that happen? Okay, now passing makes pointer from integer without cast. Okay. So what's the type? After just for reference. What's the type? These are all uint32t's. So I guess I need to cast this to a void pointer. Is that what region alloc expects? Yes, it does. Oh, ooh. It's weird. Okay. Same deal. Maybe I'll just void. Oops. Yeah. Does this work? Yeah, there. Okay. So this thing is awesome. Now I'm trying to do pointer arithmetic on a void pointer. Man. Actually, no. I'm trying to do pointer arithmetic on ints. All right. Or you know what? Yeah, I'm gonna make this dest vadder, and I'm actually going to make this just a char. Not necessarily the best form, but it's not really a char point. Although that's kind of confusing. Maybe I won't do that. Maybe I would rather. Is uint pointer t convertible to void pointer automatically? I don't think so. This might be kind of ugly. So option one is I can, like, if I want to just be very consistent with my use of dest vadder and never use this thing again, which I kind of want to do, it's a void, which is easy for here. Here I need to do some arithmetic. Maybe I'll just, but I would rather not name it. So I think the messy thing I can do is this, which is like gross. I could also name this, or void mset start vadder. Maybe naming things helps out a little bit. Okay. Set start vadder. Then really it's here. So now I have this very nifty thing, and that's actually what I want. So mapped len represents this like full thing. This is mapped len. And now to determine this length, I need to take mapped len and subtract the file size, I believe. Yo, Glenford. Hey, nice to see you. Hope you're doing well. Thanks for coming back. We're in the middle of some hardcore elf loading. So, mapped len. Yeah, I'm kind of curious how well this works. Like what? I feel like I messed up the formatting like crazy somehow. Right, does this compile? It compiles. And I am curious if it works. Yet again, this would be a great point to have some debugging features for the page tables, which I stubbornly didn't build. But maybe rather than trying to do it all at runtime or like test it manually, I can lean a bit more on my unit tests or whatever. So let's say this worked. Well, maybe just first off, I'm kind of curious just to run the code. End of load I code. So we hit the panic. So that's a good sign, at least. Okay, so now, I don't know, I'm going to move on to this next thing. And it says now map one page for the program's initial stack at virtual address. Use stack top page size. Let me just quickly look at the memory layout. Because there are some rules about which functions I can use. Like boot map region. No, but I need to yeah, I need to allocate. Boot map region only works if you're just directly trying to map regions of physical memory, like virtual memory to physical memory. But in this case, we also need to actually allocate by calling page alloc. So I think I actually need to right. So I was asking region alloc e at u, was it u stack top minus page size. If that works, it's probably going to give me a casting error or something. And I'm trying to map one page. And I need to memset I'm just going to, I'm pretty sure this is going to give me a compile error. Yeah. Yeah, pointer from integer without cast. Void stack top v adder equals. Now I'm trying to learn Vim a bit better. I still have this in my register, right? My 0 register. So theoretically, I should be able to do this. Yeah, nice. To get that without copying it again. And then I can just do stack.vadder here. And I need to cast. A lot of casting. So does this work? This compiles. Good. Memset at stack top v adder with zeros for page size. It would be kind of nice to make region alloc able to do that also. But whatever. I'm not really concerned with amazing like code design on this version of the OS. I'll do that later. Okay, let's just run it again. Let's run it. And oh no, it's back. What did I do? Man, that's so interesting that whenever you just mess up, it reboots all the time. That is fascinating. For some reason, okay, man, okay, we're back like yesterday, like last week. Why is mem setting that? Oh, wait a second. No, I am doing this. That's bad. I was doing that in the kernel's virtual memory, which was not correct. It's very important that I switch to the user page tables here. I do everything within the user page tables, and then only at the very end do I, yeah, basically switch back. And it would be so great to not repeat this twice. But I need a way to go. I need a way to fail. I wanted a way to fail here cleanly. Yeah. I'm not gonna worry about that right now. So let me try that again. I don't actually really know what happened there, but I have high hopes. Okay. So something interesting happened where I was accidentally. Oh yeah, that's okay. Here, so I was mapping memory into the environment, and then trying to access memory in the kernel, which was not mapped, which triggers the triple fault and reboots the computer like forever. That's why. And now we're not seeing the reboots anymore because now I didn't accidentally switch back to the kernel's virtual memory. I'm still within the user, like the process's virtual memory. And so therefore, oh wait, I'm stupid. Okay, so I wasn't even running anything. Right, but please let me be right. I really hope I'm right. Okay, no, I'm wrong. I'm so wrong. What's going on? Jesus. All right, what? Okay, never mind. I don't know anything. I could have sworn that was plausible as an explanation, but we are just like rebooting a million times, which is, man, kind of triggering. That's such scary stuff because it means there's some kind of crazy bug. Okay, very fascinating. Why? What is going on? So if I just run this code, I tried to, can't see the end of the line. Oh, whoops. Thank you for the heads up. I always forget about this thing. All right. All right. What is going on? So this works. I'm able to region outlook. But then when I mem set, that's when everything goes wrong. So I'm just going to try something. Am I able to all right. Am I able to just like manually top the adder equals 0? Also, why is it giving me a compiler? So my guess is that this is also going to show the issue. On any attempt to write to stack top the adder, that's probably going to trigger the issue. And it triggers the issue. But if I only attempt to read, that is probably, let's see, is that fine? That would be interesting to observe. That's fine. It seems fine if I just read. So to me, this is smelling a lot like some permissions. Something with the permissions. Maybe now would be a good time to implement like a helper command here so I can dump some stuff more easily. But it's also just kind of, yeah, no, maybe it's time to do that. What I want to validate are the page directory entry and the page table entry for this pointer. All right, let's do it. Let's just go ahead and implement a basic utility, which I don't even know. I've never done this before. How to type help for a list of commands. I've never added a command to this thing before, but I'm going to do my first one right here. So I can what do I do? I need to add, so I don't know, int mon dump, I guess. Dump, and I'm gonna add my, so I'm trying to dump the page tables. Dump VM dump. That's a good one. VM dump, or maybe PT dump for. Yo, what's up, Afnan? Lord of the White Theme. Good to see you again. Hope you're having a nice day. VM dump info about page tables. And I'm just gonna panic. VM dump. Yeah. Is it just curious, is it like nighttime for you where you are? Yeah, I mean, I'll be open to feedback about changing the theme. I would just need to find a good theme that is also still kind of light. 9 p.m. I got you. So why, interesting. There's some header, monitor.h, that's gonna be the one probably that has all these things. So I need to go to VM dump. And now this should run. And did that not work? Did that not work? Hello? What? Do I have to do something special? Help? Does that work? VM dump? Why did that not work? Wait, no, that should work, right? Cf. Does like panicking not work within this? It appears that panicking like does not work somehow. Why would that be? How, like, what does panicking do again? Yeah, that's so frustrating. It would appear that panicking doesn't work within the handler. Which is kind of fascinating. This is VS Code. I am curious enough about this to debug it. Oh shit, oops. Okay. GB. I'm trying to break in mon VM dump. Continue. That was interesting how slow it was. Okay. So the normal, oops, I don't want to step into it. And now, I'm trying to panic. Call. Interesting. Push sub if panic string. Wait, did I miss something important? Oh, am I looking at the wrong thing? There's two panics? Oh. That's why. I was looking at the wrong panic. Apparently this is the actual panic. And if we're given a string, then it just goes into the kernel monitor, which is why that makes sense. I see, okay. Achieved full understanding of this. Okay, so that explains why we cannot panic within the handler. All good. So now I'm trying to like write a little tool that lets me dump, like extract, given just like an address, I want to just look at the page directory and page table entry if it exists. Yeah. So now I'm trying to argc argv. Interesting. So, all right, if. But what is argc, or how does this thing work? Parse, gobble white space, yeah, RV. Okay, I think this is should be pretty straightforward. So if argc is not equal to 1, return -1 or something. I don't know. I don't know what the return, like, well, how is this return value used? Run command. Who's calling this? If the thing returns break. Okay. So I'm just gonna return 0. Okay. Otherwise, I need to convert this text into a number. How do you even do that again? How do you use like scanf or something like that? Does scanf exist? Obviously not. Man, that's super, it's like a little bit annoying that I don't really want to code that right now. cprintf. Oops. What functions, do we even have anything close to that? All right. Question is, do I want to implement a function takes a string and produces an int? I kind of don't want to do that. I kind of also don't immediately remember even how to do that. I wanted to support hex numbers too. Interesting. Yeah, it's okay. I'm getting the sense it's a bit of a distraction that I don't really want to spend time on here. So I'm just going to try to debug this issue without having this thing. And what I'm going to do is my usual things. So I'm going to try to do a page lookup. And page dir given the stack top the adder and the pte pte null struct page info p. How does that look? Assert p, assert pte writable And what happens if I do this? Thank you. That works. So it would definitely seem like the PTE is writable. So let's take a look at the page directory entry. Equals page dir add ptx stack top vadder assert pd. I'm very curious. Here's my theory, is that this assertion is going to fail. For some reason I don't really understand. Yeah, let's take a look. That would be great if it failed, because that would be an issue. Okay, no. It didn't fail. Which means I have no clue why this breaks everything. Does it still break everything? Yes, it still breaks everything. Okay, seems like life for me is just constantly debugging virtual memory errors and bugs at this point. It's too bad. Hey ha, how can I be a kernel developer, please? I don't know anything. Man, I mean, it's kind of a long journey. I'm gonna recommend you my resources, but probably kernel development might be a little bit too difficult if you don't know anything about programming. Just to be honest. So yeah, go learn Python, go learn a bit of C, and then when you're very, very, very comfortable with those, maybe you can try out kernel development and do the same thing that I'm doing and follow this course. That's personally what I'm doing. So learn kernel development. Okay, well, looks like I am yet again debugging a crazy reboot bug without any clue how to do that. I mean, I know a bit more because I did this last time, but yeah, what drove you to kernel development? I just like things that are very technical personally, and kernel development is extremely technical. So yeah, just kind of curious about going deeper, learning what's below the levels of abstraction that we usually work with. Yeah, that's pretty much it. And it's just cool. It's just cool to be a kernel developer, straight up. So question, am I doing this check right? Let me do some print effing. What? Okay. So 08. Interesting. I am just looking at that address. Something is a little bit off about that, so time to come back to the trusty manual. So the thing that looks wrong is that it's 001, which actually means that the writable bit is not set. It's 0. The only bit that's set is the 1 present bit. Which I'm so... Did I do this check wrong? I totally did this check wrong. Come on, wow, noob hours. The check is wrong. I used an or instead of an and. Noob hours, okay. So that is actually a little bit nicer because now I kind of have a rough understanding of what the bug is. The question is, why did that not get set? So it's the same problem as last week. We're trying to access memory that is not writable, and it's not writable because the page table entry is not writable. It's not writable because the page directory entry is not writable. And I thought I fixed that last time, but our assertion fails that the page directory entry is not writable, which I'm pretty confident I can debug pretty quickly. So let's take a look. So who is responsible for making that writable? Pretty sure that's going to be region alloc. And region alloc. Okay, this might be another case of accidentally not using the right page directory. I wonder. Because region alloc definitely passes writable in here. So let's take a look. Okay, this is okay, that's definitely wrong. Okay, I think it was exactly the same issue. Let's test it. Okay, I think that didn't really reveal anything. But now let me go back to load iCode. And actually enable this thing. I think that might have been it, actually. That is kind of interesting. That is actually very interesting that boot map region had this bug, and also my other functions seem to have this bug. So now this seems to be working. So I think I fixed the bug. Does the mem set work? That's what I'm curious about. And that works, okay. Whew, okay, so good that I didn't need to spend another like 3 hours debugging that, because it was such a familiar bug. But now that's actually very interesting and makes me want to like audit all this code a lot more. Is there anywhere we're using current page dir inappropriately? No, this is all right. This is right. These are all asserts. Page dir walk. No, that's that's right. So all tests. Okay, I'm hopeful that that was like that was like the last place. But it was again the exact same issue where I accidentally hard-coded the function to only work with the kernel page directory instead of being kind of a generic function. What about this? I mean, this is all, yeah, this is totally kernel only. Okay, so let me commit this. fix. Yeah, propagate permissions just to be perfectly. Okay, so that's actually great news that wasn't an insanely painful process to debug. And now we can go back to our original quest, which was to map a stack and clear it, which is now working. Quick double check on that one. That it's working. And so that's just right here, normal user stack. Yes, oh yeah, right. So now we're here. End of load iCode, and I can even remove the panic, and we should now hit the panic at the end of the checking function. Okay, check load iCode, and we totally do. So, cool. So now here's the part where we're trying to see if the code even works. Does the code even? So how would we test this? So we have the end, so we can do some queries on the page tables, I guess. It's a little bit annoying. So, because we would kind of need to parse the elf again, unless we return some of that info here, which I don't really want to do. Okay, looks like it's time for a 20-second break. Be right back. Okay. Well, yeah, so basically the idea is I want to be doing those very similar kind of calls I was just doing for debugging. Wait, what's the first argument? Is it it's like the page directory, right? Okay. Or and dot page dir. And for example, I want to query this address, which I will just hard code for now, which is kind of bad. And is it really kernel dev? Can a single man develop a kernel? I think you are fake. I think a kernel can run on PC without other OS. Is your kernel can? Nah, you're right, dude. I'm fake. I've been called out as an official fake kernel developer. Time to go home. Right, so now I'm trying to assert P It's basically just the same kinds of checks. It's just like read, write. Yeah, and so there's like all sorts of checks we could do. So mem size 12, alignment. So it's read writable. The one thing we're not really honoring is that this program header should not be writable actually, but we're actually making it writable, even though it should not be, which is kind of interesting. I don't think the class has said anything about that yet. So maybe can you run your kernel on PC without another OS? No, my kernel does not even like run. My kernel is like does not even boot like to any definition of it. And also I have never even tried it on a PC. I run using Kimu as the emulator. So straight up, no, my kernel does not work in any sense of that word. So neither on PC nor even in the emulator. Assert. So yeah, I want to test a bunch of stuff. I want to assert. I want to assert with the pt3. I want to assert that it is writable. But really the most important part is actually just that all these things, I'm just going to put this in a bit of a separate section. Just for a bit more clarity. The actual just more important thing is that all these addresses in the load segments are actually mapped. That's the basic check. And maybe I will make a function to do this. I don't quite know what it will do. Check VA and takes a pt3. Yo, sorry, man. I will answer that in 1 sec. I'm just trying to concentrate on this right now. VA and basically I'm just trying to do this kind of thing a couple times. And like 0 and check VA for example, something like this. Void, something approximately like this. Oh no, but I need to pass in the page dir. Page dir, right? Cool. So now using the page dir and using VA, I want to do some basic just consistency checks. that equals page dir pdx va and I'm just going to assert that that is present. Oh man, my automated like comment subscribe reminder kicked off. Nice, cool, and very interesting that that's working. All right, and PTE present, so it should definitely have a PTE, and it should be present. And I think those are the basic checks we can do. Right, so I have no idea how to pronounce your name because it's like not valid. It's not like not pronounceable, but I'm just, I'm following this MIT course right now. And I'm working on this, the third lab, which is where we load user programs into memory. And I'm trying to validate that this works. So now I can copy in this thing. Does this work? That'd be cool. This thing. Yeah. I don't know, let's run it. Oh man. Yep, forgot the pointer. Assertion failed, P. It's actually kind of concerning. That's Oh, but wait a sec. No, I need to. Wait, no, is it? Okay, let's take it one by one. So this address should work, and it doesn't seem to. So why should that address work? The address should work because unless I did this part wrong. Maybe it's worth putting some prints in here. All right. Does that work? 1, 2, 3 P. I'm curious. Does that work? Hello? What? Panic. Is the code even running? Did I really totally screw something up and I'm not even calling this function somehow? Is this running? Use some different numbers. 8, 9, 8. Okay, so that panicked, like it should. Or now I'll just move it down to this. Okay, so that's. Is it failing? This? Is it failing the elf magic check? Did I do that wrong? Yeah, it failed the elf magic check. Holy. What? So that would explain it. What's the elf magic? E magic. Check. That is way too big of a number to be the elf magic. Is that a hex number? No way, what? Okay, I'm going to cheat and look at how the bootloader does this. I thought I did it this same way. If the elf header magic is not equal to the elf magic, fail. So what is going on? I guess it might be useful to have like a hex dump function also at this point. Otherwise it's a bit difficult to, but like what's the type of magic? Or maybe I'm wrong. Okay, I thought that it was a bit smaller of a number, but maybe I'm wrong. Okay, I would like to at least fix this before I can call it a day. All right, Handle, thanks for joining. See you another time. Peace. Have a good one. Am I? Okay, maybe it's actually very simple. So what is binary? Binary is a pointer to a buffer, right? And I was just like assuming that we could take that and also treat it as an elf header. Was that wrong? All right, I'm going to debug this. Checking the chat. Yeah, sorry, man. I'm really trying to get this done before I go, so I don't quite have time to answer all the questions. Oh wait, what? Okay, this is so. Oh, okay. I'm being so. I'm not. So. That was panicking for the first caller, which is intentionally invalid. Oh yeah. Which is the garbage thing. Okay. Kind of wasting some time. Oops. Wow. Oops. So what happens here? 88898. So it definitely gets here, right? So what I actually wanted was not a panic, but a print. Bad elf, actually. And it only prints bad elf once. I am getting kind of confused. Okay. Print statement up higher. Load icode, right? Is that our first print? Yeah. So we should see 2 of these things. Okay, nice. So first load icode, bad elf. Second load icode. And it didn't hit the bad elf. Okay. I just need to really debug this. All right, thanks, man. Have a nice weekend too. Later. So just for curiosity, 012. Is this right? Not load. Did I mess this up? If it kind of would, I've kind of thought I got that right. Okay, did I mess that up somehow? Some like really deeply embarrassing. Okay, so my something is just wrong, it would seem. Getting all zeros for the, so that's wrong. So clearly I'm parsing this badly. So time to bring up the code. So it is, okay, so maybe I'm messing up right here. Yeah, I kind of wish I had this macro that I fine. just for like printing things out a little bit more easily. Yeah, I'm just gonna do this. Okay, yeah. Kind of don't want to write the macro like live, because it's always a bit tricky. But just like, what are some things I can, easy things I can, that would loosely, allow me to verify if I'm reading this right. Oh wait, no, I know the issue. So this is, it's not, program headers is declared as an array of pointers, but that's so wrong. It's an array of program headers. But no, that's, but wait a sec, but no, never mind. It's an array of program headers. So I kind of have the feeling, I have the feeling that with the array access that works. So this is just really me being actually kind of a noob with C, like straight up. That's what's going on right now. I'm just like not getting my pointers and my memory right, which is kind of embarrassing. Yeah. I think I will just take, yeah. I kind of want to cheat and look at the bootloader, but I also kind of want to get this and debug it myself. But maybe I just have a misunderstanding of how the ELF format works, which is also possible. I'm just gonna look up ELF binary diagram just to really like kind of clarify if I'm thinking about this correctly. Can I zoom in? Okay. That is like somehow way too big to be useful. So the headers. There's the program header table. So there's the program header offset, right? And that should be here. So it's an offset from yeah, the start. Yeah. Hey, SideQuest. Yeah, thanks for watching and the brainstorming. All right, I think. Okay, I'm just okay. I'm officially just going to cheat and look at the bootloader to see what I'm doing wrong. So it also computes a program header. Yeah, I'm just going to kill this palm tree. And it uses, yeah, it does this like end program header pointer thing and advances. It seems like it just increments the program header pointer. Which is a little bit confusing to me. I mean, I still didn't quite get the issue, but I think I have some misunderstanding of what to load elf binary. All right. Let's go to the classic OS Dev wiki. Okay, let's follow these instructions. Let's perform. Verify it starts with the elf magic. Read the elf header. Read the program headers. Parse the program headers, determine the number of program segments. Load each of the loadable segments. This is an array of n entries in the following format. 32-bit and 64-bit. Is it possible? I mean, I feel like this is the part where I should just either hex dump or step into the debugger, which will be the last thing I do today. For the load I code. And continue. This is the first time. Now we're at the second time, and I'm going to step through some stuff. And now we can try to see a few things. I'm curious, does this work? I always kind of forget. I think it does. Yeah. Yeah, that actually works pretty nicely. So now we appear to be at this loop. I'm just curious. Are all my variables there? 3 program headers. And this is exactly what I want to see. 3, 2. Does this work? Program headers? No. Or yes. Why is it all zeros? Hey, Mr. Femib. Why is this all zeros? Holy. I clearly did something. My program headers point to all zeros. Okay. So wait, p binary, p elf. These should be the same. Am I going crazy? Yeah. Yeah. Thanks for the tip. Yeah, I generally avoid the text UI of GDB because it is very buggy in my experience. And also, I mean, but yeah, but yeah, thanks for the tip. So did I make, oh, I made an ultra rookie error, dude. Dang, I was doing pointer arithmetic. Binary got casted to a program header, and then I did pointer arithmetic on it. Dude, yeah, big rookie error. Okay, I'm gonna kill this and rerun things. And so now we get this other panic at N516, which is appropriate. Oh, what? Now we're rebooting again? Oh my gosh. Yeah. Oh, dude, well, thank you very much. Just trying my best to learn, but if you're inspired, that's awesome. Yeah, thanks a lot. That's cool. Okay, so you can't live without the TUI. That's very interesting. Maybe it got a lot better since the last time I tried, but yeah. Okay, so I kind of want to stop, but then it started rebooting again. So the last, like, what I'm just gonna do is check load icode. Oops. Okay, so this is still like not working, I think, which is mysterious. Panic. Okay, does it hit the panic here? 333. Does it hit the panic here? No. Okay, something is going wrong with my elf loader, and it is panicking. No, it's not panicking, it is triggering reboots when I attempt to populate and write the elf into memory. So but yeah, so that's interesting. Unfortunately, I'm out of time for today, so I won't be able to continue debugging it, but thank you very much. If you are here watching, I'm just gonna post my Discord link and do the normal stuff. Yeah, feel free to like, comment, and subscribe if you enjoy this kind of thing. I'm here every week, and I will see you next time. Have a great week. Later. Bye.